Okay, so today we're going to do Unit 2, Day 1. We are solving a system of equations using the substitution method. Our first example. So we have both of these equations here. They're both linear. We are going to use substitution. So substitution is where we plug in one equation into the other. So as I see, they're both set equal to y. So I'm going to take the negative 2x plus 5 and plug it in for this y. So another way to look at this problem is we're really just setting both of these sides equal to each other. So negative 2x plus 5 equals 2x plus 1. We're going to solve for x now. After you substitute, you should only have one variable. So I'm going to subtract 2x on both sides. I have negative 4x, drop down the plus 5, equals 1. Subtract 5 on both sides. Negative 4x equals negative 4. Divide by negative 4. X equals positive 1. Then I'm going to take that, plug that back into either equation for x. Y equals 2 times 1 plus 1. So y equals 3. Now these go together. They're both part of our answer. It's an ordered pair 1, 3. What does that mean? This means we already solved systems using a graphing method. So if I put both equations on the graph, the first equation, y intercept of 5, slope of negative 2. And my second line, y intercept of 1, slope of positive 2. Our solution is where these two lines cross each other. So they meet at the point 1, 3. Okay, let's take a look at the second one, number 2. So I'm giving you a visual this time without having you graph it. Solving using substitution, I see my first equation, y is already isolated. So I can go ahead and take 2x minus 4. I'm going to plug that into the second equation in the place of y. So this y here, I'm not going to rewrite it. When I rewrite the second equation, I have 3x plus 2. I'm replacing this y, so I'm going to open parentheses, and I'm replacing it with 2x minus 4. Then finish writing the equation equals negative 6. Notice at this step, I only have x's. So let's go ahead and distribute and solve for x. So 3x, distribute 2. 2 times 2x is 4x. 2 times negative 4 is negative 4. Equals 6. Combine your like terms. 3x plus 4x is 7x. Ooh, I made a small mistake. 2 times negative 4 is negative 8. There we go. Drop down minus 8 equals 6. Add 8 to both sides. 7x equals 14. Divide both sides by 7, so x equals 2. Good. That's half of our final answer, 2 comma something. Find our y value. We're going to take this 2, plug it in for x. I like to plug it into the equation that is already isolated. It saves me some steps in the end. So y equals 2 times x. Well, I know x is 2. Minus 4. So y equals 2 times 2 is 4. Minus 4. Y equals 0. So my solution is the ordered pair 2, 0. Our solution is where the two lines intersect. If at any point you need to slow this down, feel free to pause me. Okay. Number 3, I have x equals 3y and 2x plus 4y equals 10. My first equation is already isolated for x, so I'm going to take 2y, plug that into the other equation for x. So it's 2 instead of x, I'm going to plug in 3y. Plus 4y equals 10. Multiply 2 times 3y is 6y, plus 4y equals 10. 6y plus 4y is 10y. Divide by 10. Y equals 1. Take that, plug it into the isolated equation. X equals 3 times 1, So x equals 3. My final answer should be an ordered pair, 3, 1. Okay. Now let's get into one where we do not have one equation that is isolated. So we don't have an x equals something equation or a y equals something equation. So how do I figure out which variable to isolate? In my first equation, I have a variable that has a coefficient of 1. So that is the easiest variable to isolate. So I'm going to go ahead and rewrite this equation just to keep it kind of organized for you. I'm going to try to get x alone now. So I will add 2y to both sides. So these cancel, x equals. Now on the right-hand side, this isn't slope-intercept form. It does not matter how you write these. I typically just follow a pattern and try to drop down my y term first. So 2y minus 6. Remember, you cannot combine those. They're not like terms. Now x is alone. I'm going to take 2y minus 6, plug it into the second equation in the place of x, because 2y minus 6 is set equal to x. So I have 4 times 2y minus 6. Drop everything else down. Plus 6y equals 4. Distribute 4. 4 times 2y is 8y. Okay, combine your like terms. 8y plus 6y is 14y. Add 24 to both sides. Divide by 14. Okay, we know that y is 2, so we can take that and plug it into our isolate equation. X equals 2 times 2 minus 6. So our solution is negative 2, 2. Okay, so all of these that we've just done have one solution. Each of these lines intersect. These lines cross each other somewhere, and that's what we've been finding. Now let's look at a couple special cases. There are 3 possible solutions. One solution, as we've just seen, no solution. So this is one solution, no solution. This is when we have parallel lines, and infinite solutions, which we can represent with an infinity sign or a all real numbers symbol. And this is where, if I were to graph both of these lines, they would actually sit right on top of each other, called coinciding lines. So they are the same line, which means every point that's on one line is indeed on the other line. Whereas no solution, every point that's on one line will never appear on the other line. And here, only one point on the first line also appears on the second line. So let's look at an example. Okay, if I look at these, I want to isolate for one of my variables. So if I chose the first equation, I would isolate for y because I see the coefficient is 3 and every one of these terms is divisible by 3. Now, I'm going to save myself some steps. In my second equation, it's set equal to 0. Well, how about if I just move this y to the other side by adding y? So if 3x equals y, look at that, y is alone. If you need to see it as y equals 3x, just flip the sides. These are not inequalities, so we can flip back and forth. Now that y is alone, I'm going to take 3x, plug that into the first equation for y. So I have negative 9x plus 3 times 3x equals negative 12. Multiply, negative 9x, 3 times 3x is 9x, equals negative 12. Negative 9x plus 9x is 0, equals negative 12. That is not a true statement. 0 does not equal negative 12. So this is a false statement, which creates our answer as no solution. If I were to put both of these equations, 1 and 2, into slope-intercept form and then graph them, they would both end up being parallel lines. They would have the same slope. They would never intersect each other. Last one. Okay, looking at these two equations. The first equation is the same as the first in our other one, our previous example. Equation 2 is new. It is not isolated. However, I could divide everything by 2. And in one step, I get y alone. Y equals 3x minus 4. Now let's take this, plug it into the first equation for y. So I have negative 9x plus 3 times y, which is 3x minus 4, equals negative 12. Distribute 3. So I have negative 9x plus 9x. 3 times negative 4 is negative 12, equals negative 12. Negative 9x plus 9x cancel each other out, so I get negative 12 equals negative 12. This is a true statement. That means this is infinitely many solutions. I can write that. I can write all real numbers. I can write the infinity symbol. One last thing I want to have you note is, it's an example, so I'll zoom in here. So if I had an equation like this is, I'm just making this up, and it said negative x plus 4y equals 5, and my other equation said x equals 2y plus 10. So I have x isolated here. We would plug this into this x. I have to keep the negative there and then say 2y plus 10 plus 4y equals 5. Don't forget you're distributing a negative sign. So negative times 2y is negative 2y times negative 10 plus 4y equals 5. And then you would solve like normal. So anytime you have a negative out front, do not forget that still has to be distributed. So you must put all of this in parentheses so you don't forget to distribute. Okay, the last thing I gave you here is just an example with all the steps written out if you should need that.